Good morning, students. Today we are going to discuss a few important topics from chapter 4, and the chapter 4 is your motion in a plane. Now the first topic which we are going to discuss is the relation between linear and angular. Relation between linear velocity, linear acceleration, and angular acceleration. Now in this figure, we have considered a circular path, and on the path an object is moving. Let A be the position of the object at an instant of time t1 with the position vector r1 vector, and B is the position of the object at an instant of time t2 with the position vector r2 vector. Now there is an angle delta theta between r1 vector and r2 vector, and the object is moving with the angular velocity omega, that w, that is your angular velocity. Now in physics, basically we'll concentrate on the expression rather than on the statement part, because there is no mark is allotted in the statement. So that's why we'll concentrate on the expression part or the mathematics part. Now number one, AB arc, we have considered delta S, and delta t is the time interval between t2 and t1. Now the object is moving in a circular path. It means it has a constant radius. But we have given r1 vector and r2 vector to different symbol because they do have different direction. Okay, r1 vector is from O to A, and r2 vector is from O to B. So in the figure, you can give the arrow part if you want to give. Now magnitude is identical, modulus of r1 vector, modulus of r2 vector equal to r, and we will consider the formula arc equal to angle into radius. So r delta theta, you can write delta s. Delta s is nothing but the arc equal to angle into radius. You have got in class 10 maybe this formula. So both sides we have divided by delta t, and after that we have taken the limit delta t tends to 0, delta s delta t, and r limit delta t tends to 0, delta theta delta t. Delta t tends to 0 shows that it is the instantaneous velocity. So you can write delta s delta t, limit delta t tends to 0 as your v, that is the linear velocity, and r is the radius of the circular path, and limit delta t tends to 0, delta theta delta t is nothing but the omega, that is your angular velocity. So this is the relation between linear velocity and angular velocity. So linear velocity equal to radius into angular velocity. This is very important expression in numerical as well as in other topic. We are going to use this one. So linear velocity equal to radius into angular velocity. Now if you differentiate both sides with respect to time, v equal to r omega, you will get the expression dv dt equal to r d omega dt. So dv dt is nothing but the acceleration, and r d omega dt is nothing but the angular acceleration. So a is your linear acceleration and alpha is your angular acceleration. So linear acceleration equal to radius into angular acceleration. So this is another relation. So these are the two important relations from linear and angular. Now next topic which we are going to discuss is your uniform circular motion. So let me read out what we have written. When an object is moving along a circular path with constant uniform speed, then the motion of the object is said to be uniform circular motion. So you see in this figure, an object is moving, and A and B are the two different positions corresponding to the time t1 and t2 with the position vector r1 vector and r2 vector, and delta theta is the angular notation between r1 vector and r2 vector. Now we have joined AB as object is moving from A to B, so that is nothing but the delta r vector. Now if you have to define velocity at any point on the circular path, what we have to do? You have to draw tangent. So we have drawn tangent at A to define the direction of the linear velocity, though the object is moving with the angular velocity omega, and at B we have drawn another tangent, so that gives the linear velocity v2. Now we can draw the vector diagram corresponding to v1 and v2 by drawing two vector parallel to v1 and v2, but as the angle between r1 and r2 vector is delta theta, and r1 is perpendicular to v1 and r2 is perpendicular to v2, so whatever be the angle between R1 and R2, same angle between V1 and V2. So if it is the angle delta theta between R1 vector and R2 vector, so here is also you will get delta theta between V1 vector and V2 vector. So as the object is moving from A to B, that's why delta B goes from V1 vector to V2 vector. Now here we are considering these few parameters already we have defined in that case. As the object is moving in a circular path, so the radius is constant, and as the object is uniform circular motion, that's why velocity magnitude is also constant. So R1 vector modulus equal to R2 vector modulus equal to R, and V1 vector modulus equal to V2 vector modulus equal to V. Now we are considering these two triangles corresponding to position vector and the velocity vector. Now these two triangles is similar. That mathematics part or geometry part we have not to shown, but we have to write directly the expression. So as these two triangles are similar, that's why sides are proportion. So delta R by R equal to delta V by V, because V1 magnitude, V2 magnitude V, and R1 vector and R2 vector magnitude is your R. So we have divided both sides by delta T. So del R del T, R by V, del V del T. Limit delta T tends to 0. We have taken time interval is very less, approaching towards 0. So this gives you the linear velocity R by V, V equal to R by V, and that is your acceleration. So if we simplify, then it comes out to be your A equal to V square by R. So this is your acceleration in terms of velocity. That is this acceleration is known as centripetal acceleration. When an object is moving in a circular path, the acceleration is known as centripetal acceleration, and that one is nothing but is your V square by R. So if you want to find the force, you have to multiply both sides by m. So F equal to mv square by R. So these expressions are very common, and we are going to use this one later on. Now you can further simplify this one by considering this part. As we know, V equal to R omega as per this relation. So you can substitute in place of V square. It comes out A equal to R omega square. So 1 R goes off. Now number 5, angular velocity. So if you consider a particular circle, the complete angle is your 2 pi, and the corresponding time to move the complete circle is your time period, capital T. So unit time, angle covered in unit time is nothing but is your angular velocity. So W omega equal to 2 pi by T. I think you have understood. Capital T is the time for completing 2 pi angle. So in unit time, the angle cover is nothing but is your 2 pi by T. So omega equal to 2 pi by T. And the frequency part already you know, nu equal to 1 by T. So if you use this relation, omega comes up to be your 2 pi nu. So A equal to R 2 pi nu whole square. So it coming out 4 pi square R nu square. So these are very important relation. Please try to go through this part, and also simple geometry. So please go through and try to find out your doubts. If you have any doubts, please do ask. We'll try to sort it out. But you have to practice simultaneously and concentrate on the mathematics part rather than on the expression, because no mark is there. Concentrate on the mathematics part or the expression, but you are not supposed to write statement part, because no mark is allotted for the statement, but the mark is allotted for expression and mathematics. Okay, no mark is allotted. I am repeating once again, no mark is allotted for the statement part, but the mark is allotted for expression and mathematics part. So concentrate on the expression and mathematics part rather than on the statement, because the statement you can make and write, and try to avoid the statement as far as possible. So this is all about. Thank you.